pin myself so I can see. Nice, Mr. Dobbs. Good to see you, bud. Okay, cool. All right. Thank you all so much for being here. This is going to work a lot better, I think, than just watching the recording. So we'll do this as well the couple weeks after Thanksgiving, as we get a little further into chapter 2 and see how that goes. What's up, Griff? Good to see you, bud. So thank you for being here. Easiest way for me to take attendance is to drop your name into the chat or just say something in the chat on the Google Meet itself. So just open up the chat, type anything. You can write your name or you can just say hi. And then I'll be able to look back at that since this is being recorded and I'll know who is here. So that's awesome. Okay. We did some 2.1 stuff last week, looking at vertex form and being able to figure out, okay, where's the vertex? It's vertex form, but also figuring out, like, was it a minimum or was it a maximum based on that leading coefficient, right? Whatever A was. And we had some homework on that that I was hoping was relatively easy. Because there's really not any work to do. We just have to switch the sign of the number on the inside for H and keep the exact number for K for the HK vertex and then use A. Were there any questions about any of that? This is definitely going to be one of those kind of classes where, although I'm talking to an empty room and I'm just staring at a camera, I don't want it to be really one-sided. I would love for today and for the next few weeks that, unmute yourself like you're in class and let's actually have conversations about this. So, but if not, say nothing. Is there anything you want to look at for homework 2.1? Are you feeling okay? Okay, good. Let me know. Stop me at any point if you need any clarification. I'm happy to go over some stuff. But if we're all good, I would love to just jump into 2.2 and teach you that. And we should be able to start and finish that lesson today. You'll get a little bit of homework just like the ones we'll do today for you to work on tomorrow. And then I'll see you back here on Thursday for 2.3. Okay. My guess is 2.3 is not going to be a one-day kind of thing. We'll probably come back the week after Thanksgiving and get all together and continue it. I'll probably reteach some stuff and we'll do some extra practice with 2.3. Just know that if you don't know yet, the way it looks the week after Thanksgiving, the 2 weeks after Thanksgiving before finals, all the cohorts are getting smashed together to reduce the amount of screen time that we as teachers and you as students have to put up with. This week we couldn't manage that because we already had a day, but doesn't matter what cohort you're in, okay? The 2 weeks after Thanksgiving, Monday and Wednesday are the live days. Tuesday and Thursday are the remote ones. And when I say live, I mean I'm gonna do this for sure on Monday and Wednesday with my classes, okay? Tuesday and Thursday, probably not. Okay, so if your schedule, since you guys are cohort B, you're not used to that and you've got stuff going on, now is the time to figure out those couple weeks. And if, like, you are working, it's time to start switching schedules around or making a plan for yourself to watch the recordings if there's stuff you can't get out of. But it is so much more beneficial for you to hear this live, be able to ask questions and ask for clarification or whatever it is. Plus, I like talking to you. There you are. That's what I like. So let's do this without any further ado. I just wanted to give you some details on that. Let's jump into 2.2. Okay, I'm going to try my best to avoid like writing within the glare from the lights up here, so I can kind of see myself. So I'm going to start down here. 2.2. Okay, right? You're going to want to write this stuff down for sure. There's a lot of useful stuff today for sure that you're going to want to. Okay. Okay, chapter 2, all quadratics. So definitely going to have an x squared in here, and that's going to be the biggest exponent. And what you'll see in 2.2 compared to 2.1 is, although we're looking at quadratics, the way to write them down can change, right? Vertex form was really nice because we could see the vertex and we could look at A and figure out what we're looking at. But that was it, right? We couldn't really do much else from there. Okay, what I want to show you in 2.2 is another way to write these down where there's other important stuff that we can keep track of, okay? And this is actually probably the way that most quadratics get recorded, get written down. It's the standard way to write them, and that's why they call it standard form. Okay? The standard means the most common, right? The best way to write these down is usually standard form. Now, we're not going to be able to see the vertex, right? That was what vertex form was, but there is some other stuff that we can see. But when I talk about standard form, and this actually goes for any function, it doesn't matter if it's quadratic or not, I want to put that biggest exponent term first. I want to put that out front, right after the equal sign, so I know what I'm dealing with. So if the biggest power is 2, then x squared is up front. If the biggest power is 3, then it's x to the third will be up front. Or if the biggest power is 10, fine, I'll put x to the 10th up front, okay? So I can call this whatever I want. F of x, g of x, a of x. I'll call it f of x. I like f of x. That's kind of a common one, okay? And you're going to see that that x squared term is going to go first, and then I'm going to go down from there, okay? I'm going to put the x squared one first, then the x, then the number, okay? So when we write this down right now, I'm not going to put any numbers in just yet. I'm still going to use like the A's, the H's, and the K's, but I have to pick different letters because I can't see the vertex. But, so leave a little space right after this equal sign and put an x squared because that one's going to be first guaranteed. It's quadratic, you got to have an x squared, okay? Plus, leave a little space here. Then the x1 guaranteed to come next, if it's there, right? If we have an x, awesome. If we don't, fine, it's still quadratic, it's got an x squared. This one has to be here. This one doesn't. Okay, and then plus, and then some number, right? There could be a number at the end that we add or subtract. Cool. I just want to give them some names, okay? And what's really nice about standard form compared to vertex form is this spot right there, that first number right after the equal sign, just like it was for vertex form, right? A, same thing. And I'm going to call it A as well. I'm going to use the same letter because I don't care if I write it in vertex form or I write it in standard form. That first number is A. And it does the same thing. It's still the vertical stretch or compression. It still tells me if I'm flipping this thing upside down, if it's a reflection, right? If A is positive, if it's bigger than 0, right, it's going to open up. If A is negative, if it's less than 0, we're definitely going to open down. All of that is still true, which is really nice. Sorry, I got to multitask. Cool. But this number right here and this number right here, they're not H and K. It's not going to be the vertex, and that's okay. They're going to give us other pieces of information about this function, plus we can still find the vertex. We just have a little bit of work to do, and that's what I want to show you today. I want to show you what we can tell for sure just by looking, just like we did with the vertex form to find the vertex. And I want to give you a really nice shortcut on how to find the vertex if it's written in standard form. Okay, so I'm just going to use different letters here. I'm not going to use H and K. I'll stick with the beginning of the alphabet. Already used A, so how about B and C? Those look real good. Cool? All right. So what I want to do is kind of play around for a second. I gotta get some stuff uploaded to YouTube for my video from 6th period. At least get it going. Okay, what I'm gonna do is I'm gonna share my screen here, and I just wanna play around and see if you, all of these amazing people that are here right now, make sure you drop your name in the chat if you haven't done that yet so I can properly take attendance for you guys. I'm going to share my screen. Pull up a graphing calculator and just look at a couple. Okay. And see if you can tell me. So this is where I definitely want you, like, if you notice something, unmute yourself. Tell me what you see. Let's hang out in like this space right here. So every box is worth 1. I don't know. X squared. I don't know. Plus 4x minus 1. And can you look at this graph and look at the numbers? Right, the 1, the A, the B, the C. Can you look at those numbers? And here are all the important spots along this graph, right? The vertex down there, a couple of weird x-intercepts. That's probably not going to come up. And then the y-intercept. Is there anything that sticks out that doesn't take any work, that I can just look at this function and say, yep, I know this point for sure. And I'll even put like a second one on there, whatever, 2x squared minus 3x plus 4. And I don't know, like negative 3x squared plus 12x minus 5. Take a look. And if you notice a spot on each of these graphs that you know for sure just by looking at the equation, tell me what you see no matter what. Is there a point, vertex, y-intercept, x-intercept, something like that, where one of those numbers, A, B, or C, guaranteed to just be that number? Here, let me limit this down a little bit. Let's just look at one. The one in red is this middle one. Do any of those numbers automatically correlate to one of these important spots on this graph? The y-intercept right there, you got your x-intercept, or your vertex right there. We don't have any x-intercepts in this one. I want to hear from you. Take a shot. No guts, no glory. Give me something. Come on, you got to see something. You're there, right? I'm not talking to myself. 9 people here, including me, apparently. Let me show you a different one. I'll show you one side by side. There's the black one. Vertex right there. Y-intercept right there. X-intercepts right there. Look at this black equation. Do any numbers stick out just like the ones for the red? Somebody unmute yourself and say, I don't know, if that's the case.
So what numbers are sticking out?
Yeah, so like if you look at this black equation, if you look at the red one, Out of those numbers that are there, the 1 in front of the x squared, the 4 in front of the x, or the -1 at the end, or the 2, the -3, or the 4, do those numbers specifically point, does just one of those numbers, A, B, or C, does it specifically point to a certain spot on this graph?
I'm not sure.
Okay. Take a look at the black equation and look at the y-intercept right there. Look at that number, -1. Look at this number at the end, -1. That right there looks like it could be the y-intercept. Does that also hold true for the one in red? Is that number at the end exactly the y-intercept?
Yes.
Right? And look at the blue one, right? -5 is that number at the end. Is that exactly the y-intercept? Absolutely. Okay. And that's what I want to try to show you guys, is that when we have something written in standard form, there is no work to do to figure out the y-intercept. All you have to do is look at this last number right there. That right there is guaranteed to be the y-intercept. 0, comma, whatever that number is, call it C. Good, thank you. I appreciate you having that conversation with me. I was afraid I was talking to nobody for a while there, and who knows, maybe it's just me. But there you go. Guaranteed, I don't have to do any work. Just like the vertex, just pull out the right number, and I'm done. Okay?
So the first number is always going to be 0, comma, and then the second number is going to be the y-intercept?
Exactly, because if I'm on the y-axis, I haven't moved left or right from the origin, so x is still 0, right? I'm just moving up or down to find that number, and I mean, imagine dropping in 0 for x right here. That whole thing becomes 0. This whole thing becomes 0. The only thing that's left is C. That's it.
Okay, thank you.
Thank you. Cool. So there's my first super easy one. Here's the second thing that comes from this lesson that's a little bit more work. How to find the vertex, because we did vertex form already, so I wanted to give you a shortcut if it's not in vertex form. So A's over there, C's over here. Okay, here's the shortcut to find the vertex, okay? This is the one that's going to take a little bit of work on our part because it's not written in vertex form, okay? C's done its job already, okay? I'm going to use a combination of A and B to help me figure out where this vertex is, just because it's not written in standard form. So I don't have H and K anywhere. I want to be able to figure those out, okay? Now, if I explained why this is the shortcut, I think it would just confuse us more, like the math that's happening behind the scenes, because how to do it, like how to get to the shortcut is like 2.5, and we're only in 2.2, so we're not quite there yet. So I'm gonna save you from the proof of where this comes from, and hopefully just take my word for it now, and then when I show it to you in a couple of weeks, then you know how to do it. But not, you don't have to know how to find it, you have the shortcut. Okay, so what I'm going to give you is not super complicated, but you just don't know why it works. But trust me for now, I wouldn't lead you wrong. Okay, here it is. All right, I want both x and y. I got to find the point where this thing turns. So I can't find both at the same time. So it seems pretty logical. Like I'll find x first, and then I'll use it to find y. Right, x comes before y, so let's find them in that order. Okay, here's the shortcut, and this you just kind of have to get stuck up here for now until you get it memorized, and then you'll be able to pull it out like that. It's not super complicated, but it does take a little bit of practice. Okay, the x part of the vertex starts as a fraction. It doesn't have to end that way if the numbers go nicely into each other, but we're going to always start it as a fraction. Okay, and I'm going to use, so C is done. Okay, I'm going to use a combination of A and B to do it. Okay, and I promise you, it comes from somewhere that's been proven. It works. Okay, so on top of the fraction, if this number is B, whatever number is attached to x is B, on top of the fraction, is negative b. Now, I used the term negative a little loosely there. It's the opposite of b. So if like b was 4, this would be negative 4. Right? If b is 10, then this is negative 10. So if it starts positive, make it negative. But if b is already negative, like if this was a negative 2, right? We get to an actual function, and the number attached to x is negative 2. This is negative b. So it's like negative 2, right? The opposite of negative 2, we would change it to be positive 2. So I say negative, but I really just mean the opposite of b. Take the number and change the sign, okay? So on top is going to go negative b, the opposite of b. On the bottom, we're going to take a and double it, okay? We're going to do 2 times a, 2a, okay? And there's the shortcut. I don't have to do a whole lot of fancy algebra. I really just have to do arithmetic. I just have to plug in b up top, change sign. Plug in a on the bottom and double it. Negative b over 2a. And that'll give me the x value. To find the y value that goes with it, I just have to plug it back in. I've got a function. I have a spot to plug in my x. So I'm just going to plug it back in. Whatever this is, yeah, I end up getting 5, whatever the answer is, right? Okay, cool, nice. My x value is 5. I'm going to take 5 and I'm going to drop it in. And because remember, f of x is really just y equals, right? I just call it f of x or g of x or h of x so I can tell them apart. But really, it's a relationship between x values that we can plug in and the y values that we get back from plugging those in. And so I'm going to write good function notation here, like f of whatever it happens to be, plug in x. Just plug it in, see what you get. Okay. And we're going to let the calculator do all that work. We don't have to show the arithmetic necessarily. We're going to let the calculator do it for us. I'll do a couple where we see it all worked out so you can make sure that you can do it, but you don't have to. I'm good. Show me that you're plugging it in, and we're good to go. Okay, so y-intercept, the last number, whatever it is. Okay, no work to do, 0, c. And even if you just say y-intercept, 6, I don't even need 0, 6 because you said y-intercept, so I know where we're at. Okay, vertex, though, is a point. We got to make sure we write. All right, that's it in general. Let's actually do something so you can see this thing in real time. It's going to be a whole lot easier if you actually work through 1 or 2 together. I'll give you a couple to try if we have some time, and then you'll just practice it tomorrow to make sure you got it. So 2 things today: y-intercept, easy one; vertex, just a little bit. Okay. So I'm just going to make one up. I'm going to try to keep myself below the glare there. So call it number 1. I like f of x. It's a good one to start with. F of x equals, I don't know, x squared. I like the one that we did, that first one that I made up on Desmos there. X squared plus 4x minus 1. Okay, jot that down because, man, these problems get a whole lot easier if you have good ones to look back at. Give me 1 sec. I'm multitasking here because I've got recordings of stuff. Okay. All right, cool. All right, so here's what I like to do. And I suggest this kind of early on to keep yourself organized and to not make silly mistakes. What I like to do when things are in standard form, and I'm going to do this in 2.2 and in 2.3 because standard form is going to come back. We're going to use it a little bit differently. I like to say, and I think I'm in between the glare here, so I like to say, okay, A equals, B equals, C equals. I like to take a minute and just write down what my important numbers are without the x's, without the x squareds. Because remember, A is not like x squared. It's just the number in front, right? B is not 4x. It's just the 4. I just care about the number in front. That's why I gave them different letters, A, B, and C, so I could drop the variables and really just focus on the numbers themselves. Because if it's in standard form, it's going to be the x squared first, and then the x, and then the constant by itself.
So do you need to do anything to drop the variables?
No, all I have to do is write down the number that goes in front. So like for a, right, a is the number in front of x squared, whatever that happens to be. If I don't write that number, what is it? Like, what is that invisible number right there in front of x squared right now?
1.
Good. So I'm just going to say a equals 1.
Okay, thank you.
Because I need to use it, right? Negative b over 2a. I'm going to need to use that 1 to make sure I get x right. What's b? B is the number in front of x.
4.
Good. Positive 4, the sign matters. And then what's c? What's that number at the end?
Is it 1? Negative 1?
Good. Keep track of that sign. Good. That sign makes a difference for sure. Good. And if I start with that, I really can't mess this kind of like next step up as long as I keep track of all 3 of those numbers, okay? And that's what I'm going to do. I'm going to ask myself, I'm probably going to be asked 2 things. Number 1, what's the y-intercept? And remember, the y-intercept way back here, that's the easy one, right? No work necessary. I just have to pick out c and write it as a point. 0, because I'm on the y-axis, so x can't be anything but 0. And then whatever c is, in this case, negative 1. Y-intercept, done. No work, which is super nice. Okay? The vertex is where I have a little bit of work to do. Okay, so vertex. It's some point that I don't know just by looking. Okay? This is where I'm going to have to maybe like come down here, kind of like below where my answer is going to go, and do a little bit of work. Okay? And I want to show you what that work looks like. And really, I'm going to rely on the calculator to do the arithmetic for me. I'll do it the first time just so you see. Okay? I can figure out the x value of the vertex. So I'm going to write x equals. So that whoever's reading this knows what I'm getting. I'm going to get the x value first. Okay. And the shortcut that we know, I'm going to write that down to, without any numbers in yet, negative b on top over 2a on the bottom. Okay, and all I have to do is put the right numbers in the right spot and see what I get. So negative b goes on top, and b is 4. I wrote it down so I can't mess it up. If b is 4, then negative b is negative 4. I just have to switch the sign of whatever it was. On the bottom goes 2 times whatever a is, and a was 4. Now I just see what that is, right? Now that I've got my numbers in there, let's just do it, right? Negative 4 divided by, well, 2 times 1 is still just 2. Okay, so negative 4 divided by positive 2. Okay, so negative divided by a positive is negative because the signs are different, right? If the signs are the same and you're adding, if you're multiplying and dividing, you get a positive. If the signs are different, we get a negative. And then 4 divided by 2, that's perfect, right? That's exactly negative 2. And the calculator backs that up, so I don't have to worry about trying to remember all of that. I can just use the calculator to make sure that negative 4 divided by 2 is actually 2, which it is. And that is the x part of the vertex guaranteed. Okay, absolutely no work that I have to do there. Pass that. I got it. There it is. Not super crazy, right? It's just negative b over 2a. I just have to start getting that stuck in my head. Negative b over 2a, negative b over 2a. Okay, and that's half the battle, right? Figuring out the x value, and that's what the shortcut gives us. And that's really the only part I have to remember, because if I want to figure out the y value that goes with it, I just plug it back in. That's what this function is good for. Remember, f of x is just y equals. So if I have this function f, and I know what x is, negative 2, I'm just going to drop it in wherever I see an x in this whole thing. Okay? Everywhere there's an x, all of those x's are going to change to whatever I got, in this case, negative 2. And when I mean every x, I mean every single x. This one for the x squared, this one next to the 4, but also right here for this x. So that when I get myself down to this row right here, and I'm going to show some work of me actually subbing in -2, when I say f of whatever, if I leave that x as x, that means I'm looking at every single x. I don't want every single one. I want a pretty specific one. I want -2. Okay, so don't leave this x as x if you're going to change the other ones. Change every single x. So wherever there was an x, that's got to be 4. In the parentheses goes whatever that number was that I found from -b over 2a. -2, -2. Okay, so every single x. The x squared term, the 4x term, but also the one inside here. So that if I look at this, oh, okay, he picked function f, and he picked a specific x, -2. So I don't even have to look over here to know what's going to happen next. I know what function I'm in, and I know what x I'm dropping. Okay. Now I just let the calculator do all the rest of the work. Okay. -2, and you can do it step by step, or you could just plug it all in at once and get yourself a nice answer. Okay. -2 times itself. A negative times a negative is positive, right? And 2 times 2 is 4. So we end up getting +4, but you got to be really, really careful. Hopefully you can see kind of this edge right here. If you type it in the calculator without the parentheses, it's going to keep the negative. Because the way it reads it as like -2 squared is like -1 times 2 squared. And it's going to give you the negative version of your answer, but we don't want that. Right? So be really careful. And that's why whenever we substitute, whether it was systems, last chapter, or we're dealing with quadratics here, whenever you substitute, just drop some parentheses around any number, especially though when it's positive. Okay? -2 squared is 4. A +4 times a -2. Ooh, look, different signs, multiplication or division. So I know I'm going to get something negative. 4 times 2 is 8. Bring down that -1. Okay, so I took care of exponents first. Then multiplication. Now addition and subtraction from left to right. 4, so start at 4. Subtract 8, so 1, 2, 3, 4 gets me to 0, and then 1, 2, 3, 4 more, so -4. Put those together, and then -1 more, -5. Okay. F of -2 equals -5. That means y, when x is -2, is -5. Okay. Now that tells me what the y value is of the vertex, and that's all I really need, right? That was the whole point, was to figure out what numbers went together. And if I look at the graph of this, that's why I'm off screen for a second, so I can come back to my laptop. If I look at that graph that we looked at in black, which was the exact same function, there it is, right? There's a vertex, there's a y-intercept exactly. Okay, let me do one more with you, and then I'll give you a couple to try, and then you can kind of head out from there. I don't know. Let's just make it up. Let's just make it. There we go. All right, let's do another one. But you're going to see it's going to be really similar. I'm just going to mess with some of the numbers. I'm just going to change what A, B, and C are. I'm just going to pick some new numbers. But most of the time, I'm going to try to pick nice ones. I want to pick numbers that don't necessarily end up with fractions or decimals at the end, but sometimes they do, and that's okay. All right, we're going to get decimals sometimes. I'll just try to make them easy. I won't, I'll try to avoid things like 19/7 or something weird like that, so you don't feel like you messed up, even though you might have done it right. I'll try to keep things nice. All right, number 2. Am I up in the glare? Yeah, a little bit. Okay, I'm going to come down here. Let's change up the name of the function. We did f of x. Let's do g of x. I don't know. Let's do like 2x squared. I don't know. Like minus 16x. Minus 10. Minus 10. Okay, so 2x squared minus 16x minus 10. Okay, and what I love to do to start is I just kind of come over here and I say, okay, A equals, B equals, C equals, because if I pull out the numbers that matter, the rest takes care of itself. Okay, A is the number in front of x squared, just a number. Okay, and for us, that's 2. Okay, B is the number in front of x. What's that one? What's B? Sign in front matters, right? So that's negative 16. And C is the number at the end. That's negative 10. Keep track of that sign. If it's positive, it's positive. If it's negative, it's negative. And now I can go from there, right? I can tell what the y-intercept is just by looking for the right number. And that number is always C. Not to do any work, okay? And you can write it as a point, 0, comma, negative 10. Or seriously, like you could just write negative 10. Because you labeled it the y-intercept, so I know what x is. X has to be 0. If you're on the y-axis, I haven't moved left or right yet, so I'm good right there. Okay, the vertex, though, I can't tell just by looking. I got to do a little bit of work. And that work is always the same. X equals, and I like to do this negative b over 2a. Okay. Then I just drop in the numbers that I know go in those spots. But I just got to be careful because I know that this negative up here is going to throw us off a little bit. Remember, it's just the opposite of b. Change the sign, okay? And since b up here is already negative, when I do the opposite of that, I get a positive 16. Okay? I'm not going to keep the negative. The idea is to change the sign, make sure it's the opposite. Okay? Because remember, that's the horizontal shift, right? Where I'm going to slide it one way or the other, so I better switch the sign. Horizontal transformations are back. And then the bottom goes 2 times whatever a is. And the first one, a was 1, so it just stayed 2. But in this case, number in front of x squared was 2, right? So 2 times a, okay, 2 times 2. 16 divided by 4. And I picked nice numbers. 16 divided by 4 is 4. Okay? And so I know that that's the x value of the vertex. That number is going to go right there. Guaranteed. Okay. The y value that goes with it is something I have to look for as well. But I've taken care of the shortcut. The shortcut is the negative b over 2a for the x part. And I always start with the x because x comes before y anyway, so I might as well start with the x. To figure out the y that goes with it, plug it back in. That's what the function's there for, to give us a way to find what y is. Okay. Now, because it's g of x, I better call it g. Right? I don't want to say f of whatever. That was the first one. There's a reason I named this something different, so that when I come down here and I'm showing you that I'm picking this function to drop that x value in, I call it g of whatever. Okay. Whatever the name of the function is, make sure you repeat that throughout that problem if you're looking for y's. Okay. But I don't want to say g of x, because then I'm not plugging in an x. I'm just leaving x as x and looking at the whole thing. I want to look at one specific point on this graph. Where? Right there. Right? I know what I want. And so wherever there's an x, okay, here there was an x, so parentheses. Here there was an x, so parentheses. Here there's an x, so I'm going to hold on to those parentheses, but I'm going to leave that spot for a number, not just for a variable anymore, right? In goes the 4. Now, be careful how you write this, because the only thing up here that's being squared is just the x. If they wanted that 2 that's in front to also be squared, they would have put parentheses around it, right? Let me lose this for a second. They would have done like this. If they wanted to square the 2 also, they would have put the parentheses around it, but they don't. We just want to square the x, and that's what's going to happen. I'm never going to put that other number inside there. That's what standard form is. No parentheses, okay? So I'm going to square that. And seriously, I'm just going to go into my calculator, and I'm going to type this whole thing in, all in one shot. Okay, I'm going to show it to you on here so you can see it. Present my whole screen. I just want to see you write down what I just wrote down. Okay, I don't need to see everything else. I want to see the negative b over 2a. I I want to see you show me that work of G of 4 equals, right? That whole thing. But then from there, just do that, right? Type in whatever you've got and tell me the answer. Okay. For me, was it negative 42? Boom. Done. Okay, I'm gonna stop sharing. That's what I'm thinking. You want to show me every little step along the way, that's fine. But you really don't have to. Okay. If you want to say here, I'll even write it over here, right? You can just kind of, like we did with the x, create that train of equality from left to right and drop it in like that. Or you can do the whole thing. Okay, exponents first, 4 squared is 16. No multiplication yet. Okay, now I multiply 2 times 16, 32, minus 16 times 4, 64, minus 10. Addition, subtraction from left to right, and you'll get negative 42, right? This number is always twice as much as this. I don't know if you noticed that, 4 and 8, right? Second number is always twice as big as the first. This number is twice as big as that one. This is kind of nice. Done, there it is, negative 42. This number, what was the point to do that? There you go. That's how that's gonna work out. Quick. Questions on that? Those are the two things from 2.2. Okay, being able to find the y-intercept super easily. No work at all, it's just C, whatever that is. And then being able to find the vertex, right? Because that was really nice in vertex form, but now that we're not in vertex form, I want to know how to get there, okay? Negative b over 2a can do that. All right, cool. I'm going to slide you over to a little bit of practice. Let me get a little slightly better angle there. It's kind of glared. Let me see if I can reduce some of that glare. If I slide you over. Yeah, there we go. Nice. I know the angle is a little tough. I literally have 15 textbooks, all 15 stacked on those two desks over there. So I'll read it to you. Try them out. I'll do the solutions so you can see them. I'll go over whatever you want, but really it's just a little bit of extra practice to get you ready for homework 2.2, which is what you'll do tomorrow on your remote today. Okay. So I'm going to read them out loud in case you have trouble seeing them, and then you can practice them. Or you can head out. It's up to you. I would stick around just because we have these last 5 minutes, and just make sure you can do them. So number 3, a of x equals x squared plus 6x minus 10. Okay, number 3, a of x equals x squared plus 6x minus 10. B of x equals, for number 4, 3x squared minus 12x plus 8. That's b of x equals 3x squared minus 12x plus 8. And then the last one, number 5, c of x is negative 2x squared. Negative 2x squared minus 10x plus 11. Do the things we've been doing. Find the y-intercept and find the vertex. Okay, and I'm telling you, the best way to start, switch colors here. A equals B equals C equals. A equals B equals C equals. A equals B equals C equals. So if you have those numbers, you can do everything. Okay, I'll give you a minute to start, and I'll start jotting down some answers, just so you have good work to look back at. But if you're confused, if you're stuck, ask me. Okay, I'm here. Right, let's take a minute. I'm just going to go fill up my water. Thirsty and talk a little bit. And then I'll come back and I'll put some answers in. Okay, I'm back. 5 is just a little tricky because it doesn't quite work out the way we would want when we do the vertex. The y-intercept is always going to be, we don't have any work to do. The vertex might throw us off a little bit. When we do that x equals negative b over 2a stuff, x equals negative b over 2a. So b is already negative, so I've got to make it positive. And 2 times negative 2 is negative 4. 10 over negative 4 is not perfect, right? It's not a whole number because 4 doesn't go evenly into 10. But when you plug in the calculator, you do get something nice, right? Relatively nice, negative 2.5. Okay. And since that decimal has an end, we can use it, right? If that was like negative 2.3333333 forever like that, then I'd have to use the fraction version. But this one's good, so I'm going to use that one. I like that. Negative 2.5. There's the bell. So pretty good time. And then I just plug in negative 2.5. And this is a big reason why I'm going to use the calculator to do all this work. I do not want to try to square negative 2.5 and do all that. I'm just going to plug it in, let the calculator do the work, and it's going to give me 23.5. And you're done. Okay. Thank you guys for being here. I really appreciate it. If you're watching,
Hi, Mr. Rosengren. Thank you.
Yeah, you're welcome. I appreciate you sticking around. Homework 2.2 coming up tomorrow. Check for that. It's out there now, so you can just start it if you want, but it's not due until tomorrow. Okay, and then just check Canvas for Friday stuff. And if I don't see you, have a great Thanksgiving. Thank you guys for.
Thank you.
Thanks everybody. Have a good day.
Rosie, can I talk to you after everyone's left?
Of course.
Perfect.
Okay, looks like me and you. Here, let me stop recording.
Okay.